You stand on the shore of the ocean watching the tide come in. You sense the call of the sea beckoning to take you in further. You step forward little by little, not knowing what to expect, but expecting more. You keep going as the ocean calls you to enter in to deeper waters.
Hello everyone and welcome to the Deeper Waters podcast. I am Nick Peters, your host, seeking to bring you the very best in Christian scholarship and apologetics. And today we're going to be talking about space stuff and stuff directly related to our planet. I don't generally go into this field, but my guest is a very special guy and I'll make an exception. We are going to be talking about the book The Improbable Planet by Dr. Hugh Ross, who is my guest here. And who is he? If you haven't heard of him, he is an astronomer, the founder and president of Reasons to Believe, an organization dedicated to integrating scientific fact and biblical faith. His books include Why the Universe is the Way It Is, Hidden Treasures in the Book of Job, both of which we've talked about on this show before, and Navigating Genesis. And something else I like about him is, if you go back to listen to a past show, he's also on the Asperger spectrum, just like my wife and I, and it's great to have him back. Dr. Ross, welcome back to the show.
Well, thank you for inviting me back.
Always glad to. If my audience doesn't know much about you, though, and who you are, can you tell us a bit about how you got to be doing what you're doing?
I was born, raised, and educated in Canada. I got interested in astronomy when I was only 7, and knew that would be my future career. And I wound up getting a PhD in astronomy at the University of Toronto, and then I went to Caltech after that to do research on quasars and galaxies. And it was while I was at Caltech that I met Christians. I became a Christian at age 19, but didn't really get to know one until I met a Christian astronomer at Caltech. And he showed me how to find a good church, and that church put me on their pastoral staff. I'm still on the pastoral staff of that church. It was that church that helped me launch Reasons to Believe 31 years ago, an organization that's dedicated to developing new reasons to believe in Christ as Creator, Lord, and Savior from the book of nature. And we try to use the book of nature to get people to examine the book of Scripture.
Before we jump into the book that we're talking about today, I think it'd be good to just ask about this, that a lot of people are looking to say, well, if you believe in science, you can't be a person of faith, and science is opposed to Christianity, and it's almost as if that we could believe in all these myths of the past, but then science came along. I mean, what's your response to that kind of general critique?
Well, the scientific revolution was born out of the Reformation, and one of the great Reformation creeds, the Belgic Confession, points out that God has given us 2 books, the book of nature and the book of Scripture. And a serious follower of Jesus Christ were to be both a scientist and a theologian. And so, in fact, many books of the Bible, especially Psalms, Job, tell us that we're to examine the book of nature, and that the more we examine nature, the more evidence we'll see for the supernatural handiwork of God. And so, from a biblical perspective, you'd expect the scientific record and the biblical record to concur with one another, and then one would support the other.
Now let's start talking then about this book that you released recently, and I thank you very much for getting in touch with me, sending me a review copy. Recently you wrote Why the Universe is the Way It Is, and I gather when you write The Improbable Planet, it's kind of like you're starting with the universe, and now in this one, you're zooming in on Earth specifically. Would I be right with that?
Yeah, you're right. I mean, the book began 5 years ago. I went through the Bible and noticed that every major text on creation links the doctrine of creation with the doctrine of redemption. And also found texts that made the point that God begins his works of redemption before he creates anything. Well, that would imply that all of God's works of creation are for the purpose of bringing billions of people into a redemptive relationship with the creator of the universe. So that launched on my part a 3-year study of the scientific literature, going through the scientific literature to see whether or not it really is true that every event, every event of creation and every component of creation plays a role in making possible the redemption of billions of human beings in a short period of time. An Improbable Planet is the outcome of that 3-year study. And it's chronological. I begin with the universe, but that's just one chapter, and then I go from there all the way up to the present moment and basically make the case that indeed every event in the history of the universe, Earth, and Earth's life, and every component of the universe, Earth, and Earth's life indeed plays a role in making possible the redemption of billions of human beings in a short period of time. And for example, I'm going to be speaking at Caltech tonight to the faculty, making the point that a more efficient way to advance science is to interpret nature from a redemptive perspective.
Well, Dr. Ross, but when we look at the universe, we used to think there were just only so many planets out there, and now we know that our universe is filled with planets everywhere, and yet we're supposed to believe that ours is the only one that has life. Doesn't that seem awfully wasteful, if that's the case?
Well, what I wrote in Why the Universe is the Way It Is, and you actually see a brief comment in Improbable Planet, that the universe must be precisely the mass and the size that it is in order to make possible one planet on which human beings or the equivalent can live. And so if it wasn't for all those stars and planets and the vastness of the universe, we wouldn't be here. And so I explain, why the mass of the universe must be exquisitely fine-tuned in order to make possible those elements, carbon, oxygen, nitrogen, and phosphorus, that are crucial for life. Now, it is true that my colleagues are finding planets all over our galaxy. In fact, they estimate that there could be even as many planets as there are stars. And, there's been a couple reports that there may be as many as 40 billion habitable planets in our Milky Way galaxy alone. But what you notice in Improbable Planet, in Chapter 7, I talk about habitability and make the point that when my colleagues talk about a habitable planet, they're simply referring to a planet that would have the possibility of liquid water existing on its surface, at some part of its surface, at some part of its history. And that's how they come up with that really big number. And I make the point that that number is not at all surprising, given that water is the third most abundant molecule in the universe. The universe is really very wet. And so the fact that we see water everywhere, or almost everywhere, is not a surprise. But what you see in Chapter 7 is that for a planet to be truly habitable, it must simultaneously reside in 9 different known habitable zones. So to be possible, it must simultaneously reside in the water habitable zone, the liquid water habitable zone, and the ultraviolet habitable zone. And what you discover is that 97% of the planets that are in the liquid water habitable zone are not in the ultraviolet habitable zone. And you look at all 9, what you discover, there's only one planet we know of that simultaneously resides in all 9 zones, and that's the one you and I are sitting on.
Oh, good, I got it right. I was just trying to inject a little bit of humor in there. We look at our solar system, though, and we grew up in hearing about the 9 planets. Yeah, call me a traditionalist. I still say Pluto is a planet. But, what's the point of having all those? Is it just something that we can just look out and say, oh, look, pretty planets at night?
Well, what you'll see in the book is that our solar system actually began with 10 planets. There was a small rocky planet called Theia, and there was another planet about the same size as Neptune and Uranus. And what I describe in the book is how each of those 10 plays a crucial role in making possible advanced life here on planet Earth. So, for example, and what we're discovering is look at these extraplanetary systems, is that the vast majority have no comet and asteroid belts. Those that do have asteroid and comet belts that are 100 to 1,000 times bigger than ours. Ours is the only one that has 5 small asteroid and comet belts. But that's exactly what you need for advanced life, and it's the movement of Jupiter and Saturn in particular. Because what causes planetary systems to lose all their comets and asteroids is the gas giant planets migrate in towards the stars. And that's a storm, and when that happens, it eradicates all the comets and asteroids. So do have the big asteroid and comet belts are where the gas giant planets don't migrate at all. What's happened in our solar system is that the gas giants moved towards the sun, stopped, and changed direction and began to move outward. And it was inward and outward movement that gave us these 5 tiny asteroid and comet belts. And that's crucial because that planet Theia that we mentioned earlier, in its Earth's history, it collided with the primordial Earth. Remember where I talked about how water is very abundant? Earth actually started out with oceans that were thousands of miles deep, with so much water that there'd be no possibility of having continents on its surface. But early in its history, when the Earth was about 100 million years old, Theia collided with the Earth and caused Earth to lose all of its atmosphere and all of its water. So it became a bone-dry planet. But thanks to the fact that we had these tiny asteroid and comet belts, a thin layer of water and a thin atmosphere came upon the Earth after the moon formation event. Because, when Theia collided with the Earth, it made the Earth a little bit bigger. It led to the formation of the moon. But we have that thin layer of water and a thin atmosphere thanks to these 5 tiny asteroid and comet belts.
Now, when you were talking about the whole system with all the water going thousands of miles deep, by contrast, how deep does it go today on Earth? How many miles deep is the ocean?
The average depth is 4 miles.
That's a little bit of a change, I'd say.
Yeah, it went from thousands of miles down to just 3 or 4 miles. And, that's the optimal depth for advanced life. Any more, any less, again, we wouldn't be here.
You've talked about how water is so important for life, but why should we think that is? I mean, we can all read science fiction novels. We can easily picture that there could possibly be life forms out there that might not need water, that are material life forms. I mean, maybe there are some creatures out there that just don't need water.
Well, that was settled about 35 to 40 years ago, recognizing that life needs complex chemical bonding, which requires water. So you're literally not going to have any possibility for physical life if you don't have liquid water. That's why NASA developed the mantra, follow the water. If you don't have liquid water, there is zero possibility for life, because the only possibility for life is that it's carbon-based. Now, years ago, there was speculation that maybe we can make life based on silicon or boron or arsenic, but chemistry experiments have shown us that if you go with those base elements, that you wind up extremely short protein molecules, much shorter than 100 isomers, and it's not enough for life to be possible. Moreover, it wouldn't be stable enough. Carbon is the one element in the periodic table where you get complex bonding and stable complex bonding, and those are 2 critical requirements for life.
You've also talked about how when this planet hit Earth, that you had the moon formed. And just as we're asked, what's the purpose of the moon? It's nice for, say, going out and holding hands with your spouse as you look out at it at night, but does it really serve any purpose whatsoever?
Well, there's 22 different features of the moon that are fine-tuned that make advanced life possible on Earth. Probably the 2 that are most significant is the fact that we have this small rocky planet orbited by a single gigantic moon, relatively close. And the size of the moon and its proximity works to stabilize the tilt of our rotation axis. So, for example, you notice that the polar caps on a Mars are really tiny, and that's because its rotation axis tilts back and forth by over 60 degrees. And so it's constantly having to reform polar caps. The polar caps on Mars are due to comets bringing ice to Mars, but they don't last long. And it has because of the tilting of the rotation axis, the climate isn't stable. The fact that our rotation axis stays at about 23 degrees permanently, plus or minus a degree, means that Earth can have a stable climate, and also that tilt means that we get 4 seasons. So, and the moons, because it's so close to us, works to slow down the rotation rate of the Earth. If you go back far enough, the Earth's rotation rate was 2 or 3 hours per day. Far too rapid for advanced life to be possible. But thanks to the fact that we have a small planet orbited by its single gigantic moon, the moon over the course of billions of years has slowed down our rotation rate to the optimal 24 hours per day. And what I find amazing, it got at 24 hours per day at the same time the sun reached its optimal luminosity stability. So there's a very narrow time window in which human life is possible. The window is only about 100,000 years wide. And so it's crucial that the moon slow down our rotation rate to 24 hours a day right when we're in that 100,000 year window.
Yeah, I do like how when you've got all this scene set and here's the Earth and it's ready, it's not really ready. It's just like, as you use the analogy about the work, it's preparing a building. But if you just go and you take all your wood and steel and just start putting everything together, that building is going to be a disaster, isn't it?
Well, it's kind of the analogy we use at the beginning of every chapter, is that the preparation of Earth for human beings is the equivalent to building some gigantic skyscraper in an earthquake-sensitive city like Los Angeles. So that's kind of the analogy we used.
So we've got the Earth here, and we're going with the estimates about 4.5 billion years old. What's it like back then when it first gets started?
Well, at the very beginning, you don't have life, you don't have plate tectonics, and you got a really hot planet, and the planet's being bombarded by asteroids and comets at a much more frequent rate than it is today. They refer to this as the Hadean era, because at that time the Earth was hellishly hot and very chaotic. But eventually the asteroids and comet bombardments settled down, and what I describe in the book is a new discovery, that to sustain plate tectonics, you need light, and you need very specified light. But likewise, light needs plate tectonics. The two are synergistic. They both have to be fine-tuned together so that you can have a planet with both light and plate tectonics on it. And so the origin of plate tectonics is at the same time as the origin of life on planet Earth. I mean, what's amazing is that the first photosynthetic life forms helped by their oxygen production to precipitate uranium, and that uranium was moved through erosion processes into subduction zones, and that helped initiate and sustain the plate tectonics.
Now, I'm going to give a little bit of pushback there. It's interesting because we've seen things like the Haiti earthquake and the Nepal earthquake and such, and you hear say, well, we have to sustain these plate tectonics, and I can imagine a lot of skeptics out there in the audience saying, yeah, maintain all these plate tectonics that apparently God allows for some reason that end up killing thousands of people out there. I mean, why would we want a world with earthquakes in it?
Well, without plate tectonics, you're not going to have any means to recycle the nutrients. So thanks to the formation and the movement of continents and the slipping of plates under one another, that you get salt being recycled, so that, oceans dry up and they become salt beds. That happens with all the minerals. And so this is what enables life to be sustained at a great abundance for an extremely long period of time. If you don't have plate tectonics, that's not going to happen. And if you got plate tectonics, you're going to get earthquakes. But one of the amazing things of the planet we're on is that we have 6 different kinds of liquid water. And one of those kinds, something called class 6 water, works near the subduction zones to set up a chemical reaction that produces talc. And talc is a lubricant. And so thanks to the talc, the plates are able to slide with respect to one another without generating massive earthquakes. Mm-hmm. So yes, we get magnitude 7s, 8s, and 9s, but we don't get 11s, 12s, and 13s. Mm-hmm. So what we see in planet Earth is that given the laws of physics that the Creator chose, we have precisely the optimal frequency and the optimal intensity of earthquakes to maintain advanced life at the highest population level.
Mm-hmm. Well, I'd like to remind everyone you're listening to the Deeper Waters podcast. My guest is Dr. Hugh Ross. We're talking about his book, The Improbable Planet. But if you're here next week, you're not going to be hearing anything because my friend Chris Winchester, who has been on the show, is getting married and he wants me to be a groomsman in his wedding. So my congrats to Chris and his upcoming bride, Liza Triplet. And Allie and I are going to be up in Charlotte celebrating a wedding then. But if you're here the week after that, the 17th, I'm going to have Dr. Jeffrey Weimer on. He's the author of the book, Paul the Ancient Letter Writer. And we'll be talking about that book, about how we can study Paul and how he wrote a letter. Now let's get back to Dr. Hugh Ross. Well, let me ask you about these earthquakes, because I found this so fascinating. You talk about we don't have earthquakes of magnitude 11, 12, or 13. What exactly would that kind of magnitude do to us?
Well, a magnitude 9 is strong enough to shake the bark off trees. Mm-hmm. Magnitude 10 earthquake is 10 times more powerful than a magnitude 9. Mm. The problem with having earthquakes at 10, 11, and 12 is that we wouldn't be able to live in cities. Mm-hmm. Those kinds of earthquakes would literally level a city right to the ground. There'd be nothing but rubble left. Mm-hmm. Instead of having thousands dying as a result of a major earthquake, you'd have tens of millions or hundreds of millions dying. Mm-hmm. And yes, you don't want really big earthquakes, but thanks to the way the plate tectonics has been designed on planet Earth, we're able to sustain the tectonics without really disastrous earthquakes. Mm-hmm. And again, it's thanks to the fact that talc is produced at the subduction zones. Also thanks to the fact that uranium is precipitated into those zones that provides heat, which helps them to slip relative to one another without really massive earthquakes. And, we feel them all the time here in California, but the truth of the matter is other parts of the country are at greater risk for earthquake damage than we are here in California.
Wow.
Simply because in the other states, they don't bother to prepare. Mm-hmm. For example, Seattle and Portland are at risk of a magnitude 9 earthquake, but the building codes are such there that they would suffer damage even with a 6. So we can have a magnitude 7 here in California without a whole lot of damage, but have one like that in the Seattle area, it would devastate the city.
When I lived in Knoxville, there was a day that Allie and I were at our house, and I was just sitting in my living room reading, and all of a sudden I felt something shaking, and I thought, I can't even imagine what that is. And Allie says, "Did you feel a shaking?" Well, it must have been that. Then we go on Facebook, and other people are talking about it. It was the first earthquake we'd ever had. I think it was just like a 4 or 5 on the scale, so we did manage to rebuild by putting some lawn chair furniture back up and such.
Well, for example, the Madrid fault in Missouri, mm-hmm. When it slipped last time, it rang all the church bells in Boston. Mm. So, if that goes again, you'll really feel it.
Would this be the case also with most every other natural disaster that our skeptical friends complain about, that there is some good reason for having them?
Yes, I wrote about that in my book, More Than a Theory, how everything we refer to as a natural disaster actually is optimized for the specific benefit of human beings. So we have just the right number and intensity of hurricanes, just the right number and intensity of tornadoes, just the right number and intensity of grass and forest fires, earthquakes, you name it, it's all been optimized. Now, of course, a skeptic can say, well, couldn't God get rid of all this with different laws of physics? That would be correct. He could. However, there's a specific reason why he chose gravity, thermodynamics, electromagnetism, and the strong and weak nuclear force. Those laws of physics have been optimally designed to be tools in the hand of the Creator to quickly eliminate evil and suffering. And something we write about here at Reasons to Believe is that we see both revealed in Scripture and also in nature is a two-creation model. How this universe is created to be a tool in God's hands to quickly eliminate evil and suffering. And once it's achieved, then God will take us to a brand new creation where there is no thermodynamics, no gravity, no earthquakes, no hurricanes. None of that will be there because there'll be no possibility for evil ever coming back again.
Now, in the book, you talk about how we often hear debates about how life began and such. It looks like in the book you say that life begins, then it ends. Then it begins, then it ends. Over and over, there's mass extinction taking place. Why would that happen? Why not just have it begin and have it stay here?
You actually see a reference to that in Psalm 104, how it's the property of all life to die off, but God recreates and renews the face of the earth. And in chapter 12 of Improbable Planet, I talk about what's called the faint sun paradox. How the sun, like all stars, once it initiates nuclear burning, gets brighter and brighter as it gets older and older. And that's because in its nuclear furnace, it's fusing hydrogen to helium. And helium is heavier than hydrogen, and so as the density of the sun's core rises, it causes the nuclear furnace to burn more and more efficiently, such that today the sun is about 20% brighter than it was when God first created life on planet Earth. And that poses a paradox because life can only tolerate about a 1 or 2% change in the luminosity of the sun before it goes extinct. And God's plan all along that Earth would be packed with as much life as physically possible for as long as physically possible. And so that requires some way to compensate for the increasing brightness of the sun. And what I describe in several chapters of the book is that if you choose the right life forms, those life forms will remove a specific quantity of greenhouse gases from the atmosphere. And so if you actually look at the fossil record of life, you'll see that life begins with a low efficiency of pulling greenhouse gases out of the atmosphere, whereas today it's got the highest efficiency it's ever had. But what this requires is throughout the 3.8 billion year history of life on planet Earth is for God to step in, remove life that is not very efficient at removing greenhouse gases from the atmosphere and replacing those life forms with new species that are somewhat more efficient. And to keep pace with the increasing luminosity of the sun, you're going to want a mass extinction event about every 30 million years, quickly followed by a mass speciation event. And in that part of the fossil record that we can investigate, that's exactly what we see. And I also describe in a chapter of the book why we get that approximately 30-year periodicity. And that happens to be the cycle of the up and down movement of the sun relative to the galactic plane. Sun orbits the center of our galaxy once every 250 million years, but as it progresses in that orbit, it can move up or down relative to the plane. Now, it doesn't move up or down much. If it did move up and down like other stars do, life would be exterminated when it got too high or too low, because you'd be exposed to the deadly radiation from the supermassive black hole at the center of our galaxy. So we stay protected. However, when we do move up and down every 30 million years, we do get, well, what happens is that we get bumped around by giant molecular clouds, and those giant molecular clouds disturb our asteroid and comet belts, which causes Earth to be experiencing collision events. And we notice is that the really major mass extinction events, they're all ignited by giant asteroid or comet collisions, followed up by volcanic eruptions. There was a debate for a long time. What wipes out these life forms? Is it an impactor or is it volcanic eruptions? And the answer is it's both. The impactor ignites the volcanic eruptions.
Well, on this show, I'm not one to avoid any of the controversial questions and such. So since you talk about greenhouse gases not being protected and such, I think you say a little bit about this in the book, but I'd like to get your take on it here. What does this mean for those of us today? I mean, I'm not sure what to make about the topic, but those who are concerned about global warming, for instance.
Well, they need to look at chapter 15 of the book, because what I describe in chapter 15 is that we have this unusual period of extreme climate stability. For the last 9,000 years, the global mean temperature of our planet has not changed by more than 2 degrees Fahrenheit. Never happened before in the Ice Age cycle. Now, that's also a rarity. If you look at the history of the Earth, for 90% of its history, it's had no ice at all. Only 10% do you have any ice on the planet. But what's extremely unusual is right now we're living in an Ice Age cycle where the ice coverage varies from 10% to 23% with a cycle of about 100,000 years. And I explain in the book why that's crucial for feeding billions of human beings. It's the melting of ice left over from the last ice age that waters the great agricultural plains. And at the close of the last ice age, you have powerful winds blowing off the high plateaus and dropping dust on the agricultural plains. That fertilized those agricultural plains. So it's a combination of the fertilizer and the water that's generated by the Ice Age cycle that allows us to feed billions of human beings. But you'll see graphs in the book where I show you that throughout the Ice Age cycle, you have the global mean temperature changing by 24 degrees Fahrenheit over time periods of only a few centuries. And with temperature varying that radically, it's impossible to engage in large-scale agriculture, which explains why the human population during the last ice age was not very large. They simply weren't able to grow the food that would be necessary to sustain a large population, and for that matter, they weren't able to produce a surplus of food that enabled the population to set aside a significant fraction to engage in science and engineering and technology. So the extreme climate instability that we had, say, 15,000 years ago explains why humans at that time were not able to launch much technology or to sustain a large population. And what brought about this period of extreme climate stability were 7 different cycles in the orbit of the Earth about the Sun and the rotation rate of the Earth that all came into sync to give us this period of extreme climate stability. And I do mention in the book that that will come to an end because those cycles are now breaking apart. And as they proceed to break apart, we're going to go back into a period of extreme temperature fluctuations. And when that happens, we'll no longer be able to feed as many people as we feed today. In fact, the human population will have to drop down into the millions when that happens. But the whole message of the book is that God creates for redemption, and his goal is to redeem billions of human beings. And we're promised that once that full number of human beings has been redeemed, then God will replace this universe with a brand new creation. And I end the book in chapter 16 by pointing out how close we are to seeing that happen. A friend of mine, Ralph Winter, he's passed away, but he was the executive director of the U.S. Center for World Mission. And when he was alive, he wrote several articles where he said, evangelicals today have the money, the technology, and the numbers of people to fulfill the Great Commission in 5 years. All they lack is the motivation.
Oh, yeah.
And what I conclude in the book is God's giving us the time to finish the job. And so we can sustain the climate stability easily for another 100 years and conceivably for as long as 13 or 1400 years. Now, if you're premillennial like I am, you need to subtract 1,000 years. But yeah, it will come to an end. But, people who talk about climate global warming and climate stability make the mistake often of presuming this is the norm of planet Earth. No, it's the extreme exception. During the entire 2.5 billion year period of the Ice Age cycle, the temperature was swinging up and down literally by 24 degrees Fahrenheit. So we need to appreciate that what we see in the last 9,000 years is a special gift from God. He gave us that so that billions of human beings could live at one time on planet Earth and enjoy the technology where the good news of salvation through Jesus Christ can be taken to all the people groups of the world. And you'll see in chapter 15 that one thing that establishes that or complements that is discoveries made by us astronomers showing that we're in another unique time window where there are no nearby supernova eruptions. During the last ice age, there were 23 nearby supernova eruptions, and not near enough to wipe out humanity, but close enough to make it impossible to engage in large-scale agriculture. But for the last 9,000 years, not only have we had extreme climate stability, we've had no nearby supernova eruptions. Again, making it possible for us to feed billions of people at one time and to produce a sufficient surplus of food that we can employ large numbers of engineers and scientists.
Well, I'd like to remind everyone you're listening to the Deeper Waters podcast. And everything we do here is listener supported. And we are getting close to the time of end of the year giving. So here's your chance to get those final tax breaks in and such. How do you do it for us? You go to deeperwatersapologetics.com, our new site, and there's a link there, help support the work of Deeper Waters Christian Ministries. And you click on the link in that paragraph, you get taken to Risen Jesus. Is that the right place? Yes, that's the ministry of my father-in-law and Michael Lacona and his wife Debbie. And you make a donation there, and you get in touch with me then, or Mike, or Debbie, or my wife Allie, and say, hey, I made a donation. I want to go to Nick Peters. I want to go to Deeper Waters. We will get that donation. It will be tax deductible. And if you can become a monthly donor, that works even better. We would be thrilled to have you. You can also buy some ebooks I've written or co-written on Amazon. One I've written, such as A Creed for the Ages, and co-written, such as Defining Inerrancy, or some that would be related to what we're talking about today, God and Natural Disasters, a debate with an atheist. Or books like Groundless, for instance. And yes, I am working on a couple other books. Actually, Mike and Gary Habermas and I are all working on one together. I'm doing a lot of it. Which just you'll see when it comes out. And yes, some of you have said, please write something on marriage. Yep, that's something I plan to get started on soon. And speaking of which, one other way you can support us is by buying jewelry. We got a link there, and my friend Lena Cluster handles that. If you need some help, get in touch with me. But guys, if you buy something for the lady in your life, 25% of that jewelry purchase goes to Deeper Waters. So you can buy something to make up that screw-up that you did recently with her. Or you can buy something to make up for that screw-up that you know you're going to make in the future with her. I see Dr. Ross laughing. I think he knows what I'm talking about here. And if you can't do any of these, please get in touch with me. Let me know you like the show. Let me know you're praying for us. And go on iTunes and leave a positive review and tell your friends about the Deeper Waters podcast. Dr. Ross, is there an organization that you'd like to see people donate to?
Well, we founded Reasons to Believe 31 years ago, and just like your organization, it's entirely donor-supported. So yeah, we would appreciate any gifts that people can make that will help us to develop new reasons to believe in Jesus Christ as Creator, Lord, and Savior. Mm-hmm. We basically specialize on developing new apologetic tools. Mm-hmm. We trust others to repackage it, but we feel we need to be producing the brand new material. Mm-hmm. But I'll also say to your listeners, get Improbable Planet. It's only out for 2 months, but already we've seen a number of people come to faith in Christ through reading it. This is Christmas time. It's a great time to give a book as a gift and look for opportunities to follow up and bring them to faith in Jesus Christ.
Now, just making sure your website is reasons.org, right?
Right. Yeah, reasons.org.
Yeah, and normally I do this at the end of the show, but since you mentioned it, I'll go ahead and tell everyone right now. I'm looking on Amazon, and the price of the hardcover of Improbable Planet is $14.86, and the price of the Kindle version is $9.99. And yes, you can always recognize your apologetics geek friends, because on Christmas they just ask for books, pretty much. So yeah, if you got an apologetics geek that you know of, this is a great book that you can give them. Now let's get back to talking about this book. Now, one thing I was really looking for when I started going through Earth's history on there is something that I think every kid is interested in at least one point in their life when they're growing up. And I'm sure you already know exactly what this is, and that's dinosaurs. What did dinosaurs have to do with our world?
Well, there was a period of time, roughly 250 million years ago to 60 million years ago, when the continents were characterized by very large, shallow seas. And that made it possible for God to create large land animals, because these animals could take advantage of the water to help support their body mass. So, for example, the biggest land animals on the earth today are elephants. And that's about the limit that the laws of physics will tolerate without water support. You get animals any bigger than that, because of gravity, those animals are going to injure themselves at a very early age. But if you got, say, 10 to 20 feet of water, then you can have big animals that can take advantage of that water to support a body mass of, say, 60 to 80 tons. Mm. So it explains, and this is a principle you see in Psalm 104, that God always creates the greatest diversity of life that the conditions at that time on earth will permit. And so today we see a huge diversity of life all over the planet taking advantage of the natural conditions. But at the time of the dinosaurs, the conditions were different. And so God took advantage of that to create creatures that are far bigger than what the laws of physics would permit today on the land masses. Now, of course, we've got much bigger animals in the oceans, but that's because the water can support their mass.
I was about to ask about that. Okay, so we've got these big creatures, but why exactly? Why did we even need dinosaurs around?
Well, that's a good question, and that's a good question to ask for all of Earth's past life. Mm-hmm. And God's goal all along was at the end of the window of time for life on planet Earth, he would create us human beings. And the advantage of us coming at the very end is that we have a treasure chest of biodeposits. And so in the crust of the Earth, for example, there are at least 76 quadrillion tons of biodeposits: coal, oil, natural gas, limestone, gypsum, marble. And we've been able to exploit all those biodeposits to quickly launch and sustain global civilization. None of that would be possible if there weren't billions of years of life predating us here on planet Earth, mm-hmm. and if that life weren't maximally diverse and maximally abundant. Mm-hmm. So thank God for the dinosaurs, because they contribute to the biodeposits that we're using to sustain our civilization.
Now, I'm pretty sure someone at Reasons to Believe has done the math about this, but strictly speaking, if all we have is blind forces at work and such, what are the odds that life would come about as we know it on this planet?
Well, you can actually see those calculations at reasons.org/fine-tuning. That will pop up for you a free 300-page compendium, which gives you that precise calculation and documents it in the scientific literature. But based on what we know so far, the probability is less than 1 chance in 10 to the 1,050th power that the conditions necessary for bacterial life to exist here for a long period of time and plants and animals to coexist with them by natural processes alone would exist. And to put that probability in context, it's the same probability as someone here in California winning the lottery 150 consecutive times where they buy only one ticket each time. Or as a mathematician friend of mine put it, that probability is no different than the probability of winning the California lottery 150 consecutive times where you buy no tickets at all. The probability is utterly remote. And so we use that as a piece of evidence that life here is on planet Earth because of supernatural causation, not natural causation.
You can correct me if I'm wrong, but isn't it the case that, mathematically speaking in science, that if something reaches 1 in 10 to the 50th is considered impossible?
Yeah, that's the standard we use in physics. If you can show that something has a possibility of less than 1 chance in 10 to the 50th of taking place, that's equivalent to proving that it's impossible. For example, the total number of protons and neutrons in the universe is 10 to the 79. And so we're looking at almost 1,000 more zeros after the 1 than the numbers you would need to express how many protons and neutrons exist in the entirety of the universe.
And, some people were looking and say, well, that was just anything that seemed like God creates the universe supposedly just for us. Doesn't it seem kind of arrogant to think that?
Well, that's why I think they need to read Improbable Planet, because I make the case that literally everything you can investigate in the universe, our galaxy, our solar system, the Earth, the history of life on planet Earth, every bit of it is crucial for making possible the existence of human beings in the numbers that we have during this brief window of time. Thing points to humanity. And that's something you'll see in that reasons.org/fine-tuning compendium, is that there's a certain level of fine-tuning design that you see for bacteria existing for a short period of time. It goes exponentially, that fine-tuning, if you want bacteria that hangs around for 1 billion years. It goes up exponentially again if you're talking about the fine-tuning design you need for plants and animals. And then it goes up exponentially even farther if you're talking about human beings, and exponentially again if you want a planet on which billions of humans can live, hear the redemptive message, and respond to the redemptive message. So what you actually see here is the universe is designed for specific purposes. And the key purpose is to make a home for human beings. Literally billions of us can come into an eternal relationship with the one that created everything. For skeptics, I would say, put it to the test. Actually examine the record of nature and see if indeed every component points to the possible existence of human beings at that large number.
Now, I'm pretty sure that in some ways the scientific community does work in this regard, just like my world of New Testament, where when a book is put forward, it's also kind of a thesis in saying to the scientific community, hey, read this, critique it, say what you want in the New Testament world, we say it to New Testament scholars. So there's always more research to be done. What research would you like to see other scientists do that you've presented in this book that would further back or maybe even not back what you've said?
Well, there's a big section in the book about how anomalous all of our elements are. I think that's a very fertile area of research. I don't know if you saw that movie, The Martian, and it showed Matt Damon growing potatoes on Mars. When you actually look at the chemistry of the soil of Mars, you would realize the only way you're going to grow food on Mars is to import dirt from the earth. And you'll see a whole chapter in Improbable Planet on dirt. We take dirt for granted, but our dirt is amazingly designed to make possible the growing of vascular plants, which is crucial for feeding billions of human beings. But I suggest research all the way through the book where, if we actually take this redemptive perspective, I think we could rapidly advance or make it more efficient the advance of scientific discovery. Yeah, the elements would be one thing I'd love to see studied in more detail. Okay, but to what degree are all these elements anomalous on Earth? Why are they anomalous? And why must they be exactly the way they are in order to make possible billions of us living here? Yeah, I mean, we live in a very unique planet in the sense that no other planet has the abundance of elements that we have.
Now, I'm guessing, though, that when the reader finishes this book, you probably want them to have a lot more than just some cool scientific knowledge they can pack away. Am I right with that?
Well, yeah, a lot of people who aren't believers read the book and said, boy, this is sure fascinating. I love everything that's in here. But then they get to the last two chapters and say, hey, this all has a point. And, for example, when I was at Caltech, I knew scientists who were having so much fun doing their scientific research. I mean, it's almost like an addictive video game. So focused and passionate about making these discoveries that they got distracted. I mean, I'll give you an example. I debated Peter Ward, an atheist, who is an atheist paleontologist. And his comment to me was, I've always called myself an atheist, but the truth of the matter is I've never even thought about death. I haven't really asked myself the big questions. And I have so much fun doing my science, I simply don't take the time to ask the big questions of life. I see that as one reason why God said, work 6 days and rest on the seventh. Each of us needs a day out of the week where we focus on the most important issues of life. Otherwise, we get distracted. And science can be very distracting.
Well, what about readers who aren't distracted much the same way? What do you want your Christian readers to walk away from this? I mean, obviously you want them to have more than just scientific knowledge, so what do you want them to have?
Well, I want them to be motivated to begin sharing their faith. I mean, with this kind of evidence, it's like everybody's got to hear this, and there's a point to all this. And so, I mean, as I point out in the end of the book, there isn't much time left before climate stability we're enjoying is going to end. This is the time to spread the Christian message. And, why wouldn't I spread that Christian message? I mean, look what God has done for me. How different my life is today than it was when I was not a Christian. Don't I want everybody to have that same experience? And now God has given us tools that make it really easy to share our faith. And for that matter, it's a command to all Christians. Always be ready to give good reasons for the hope within you, with gentleness, respect, and a clear conscience.
One can really imagine, it's been said before, what the Apostle Paul would do if he had all the means we have of evangelism today.
Well, I think he gave us a good model. I mean, look at the way he would share his faith. And so I think, that's a good model for all of us. And but yeah, I think there's no more exciting time to be alive than in the 21st century. This is the time when we're seeing discoveries showing the handiwork of God happening literally on a daily basis. That was not the case in the days of the disciples. It is now. And so God is giving us new reasons to believe literally every day. And that's what I do with my Twitter site, is I alert people to the latest scientific discoveries that are giving us more evidence for the Christian faith. So every day, God's giving us new reasons to believe.
And if I'm remembering correctly, at your site, you pretty much do have, just like that, new reason to believe every day. And I think one of my favorite features in the past has also been the astronomy picture of the day.
Right. Well, I mean, all of us scholars at Reasons to Believe write blogs. I write 2 a week. Mm-hmm. And, I'd love to write more, but I'm busy doing other things. Mm-hmm. It's great that people can actually share. These are articles that are about 1,000 words long, but there's something you can actually give to your non-Christian friends and say, look, here's some new evidence. Check it out.
Mm-hmm. Well, Dr. Ross, it's been great having you on again. You're one of my, I would say that last time you were on here, that conversation we had about Asperger's and such, it was one of my best hours, I think. The show was just such a fascinating conversation. It's great to have you as a guest and a friend both. If someone wants to find out more about you, I think you've already given it again, but can you give it again? What's the website where they can get in touch with you?
Yeah, reasons.org.
Mm-hmm. And do you have any final words you'd like to leave with the Deeper Waters audience today?
Well, I'll close with what I've already said. 1 Peter 3:15. Always be ready to give good reasons for the hope within you, with gentleness, respect, and a clear conscience. God is every day giving us new reasons, but it's really crucial that we present those reasons with a Christian demeanor, because people pay more attention to our demeanor than they do our words.
Mm-hmm. Yeah, I'd like to remind everyone the book is The Improbable Planet, and right now it looks like number 14 in books on theology, listed in creationism, but number 6 in my Kindle store on science and religion, and number 19 on apologetics. Just pretty good at this start here. And it's on the hardcover it's $14.86, and my Kindle is $9.99. And Dr. Ross, thank you again for coming on, and I really do hope we'll see you back here again sometime.
Oh, my pleasure. Thank you.
I'd like to remind everyone that next week I'm not going to be here. Congratulations, Chris and Liza. I'm getting ready to come up and see you. Week after that, we're going to have Jeffrey Weimer coming on. We're going to be talking about his book, Paul the Ancient Letter Writer. For now, I am Nick Peters, and I am signing off.